Hello, I'm Jared Letty. I'm a research scientist at TechX, and I'm going to be taking you through a simulation of an SRF cavity. These are used for particle accelerators to provide acceleration to the particle as they move through the cavity. So I have a picture of the cavity up here. This is a 7-cell cavity. As you can see, there are 1, 2, 3, 4, 5, 6, 7 cells. In general, when first simulating an SRF cavity, we're looking for the fundamental frequency of the accelerating mode in this cavity. So to simulate a cavity like this in VSim, what we do is drive a current in the cavity that will create an electric field that resembles the resonant electric field we are trying to excite. In the case of an accelerating mode, or a pi mode, that means we will have alternating signs of electric field in each cavity. And not only will they be alternating in space, but they will be also oscillating in time at a particular frequency. And it's that frequency that we want to know, that we want to ensure we can simulate correctly. So I know for this cavity it was designed to have a frequency around 1.5 gigahertz. So what I will do is drive a signal that has a frequency spread something like 1.2 gigahertz to 1.8 gigahertz. And then what should come out after we drive this current and then take away the drive is the fundamental frequency should resonate and continue to ring long after we stop driving the current. And then we can look at that signal and measure the frequency of it, and that will tell us what the fundamental frequency of this cavity is. So I'm going to break this video up into parts because it's a fairly long process to get it set up and everything done correctly. So I'm going to cover the setup first, which is going to be loading this geometry into VSim, and then setting up things like constants, where we have things like the size of the grid, the resolution, the frequency that we expect, and then the parameters, which are derived quantities using those constants and other physical constants. So this can be things like, just the grid spacing, for example. And so we'll go through all those. We need a function or two to drive the current. So we have a current function here, and we have a sine function which will basically alternate the direction of that field. And then I'm going to go through the space-time functions, the materials we're using, the geometries, the grid itself, which you can see here, the fields, the current distribution, which we're going to be driving, and then finally the histories that we want to look at as we analyze what's going on in this simulation. After we do the setup, we'll then run the simulation, we'll do some analysis on the data, and we can visualize the results.